Okay, so far we have talked about these problems from the point of view of if we have a certain gross production X, then how much will be output from each sector, the Y, and how much will we have as a surplus, the S. So, what if we take a look at this from a completely different entry point? What if we look at it backwards and we think about how much surplus do we actually want to have? Because perhaps we have a certain outside demand from the market that we need to make sure we meet. So if we have a certain demand that we need to meet, the demand vector, then how much do we need to go back and how much should our X be? What should our gross production be so that we can not only meet the demands of the internal process, but also meet this very specific demand for a surplus that we might have? Okay, so to answer this, basically I've went through here and done all of the matrix algebra that gets us to the important equation that we're going to use. You will never have to remake this, but if you're interested, this is where this equation comes from because it's quite a complicated equation. Basically what we're saying is that, okay, we're going to set that demand, whatever the demand is, equal to the surplus because we already, if we can create enough surplus to meet that demand, then those two are the same. We already know how to create the surplus by doing x minus this should be a y here. And these are just, all I did was a bunch of substitutions, where I can slap an I matrix in front of anything I want because that doesn't change things. And then I can factor out and I can multiply by inverses to do some algebra with things. And basically it gets us down to this equation. So I've just provided the proof of where this equation comes from. This is what you need to know though, that if you are given a specific demand and you want to work backwards and find that X, that you need to use the equation that X equals I minus A inverse times D. So of course the inverse has to actually exist to do that. If you ever run into one where that doesn't exist, then you can't do these problems. Okay, so it says, what must be the gross production of this economy to meet a demand for 78 tons of coal, 15 tons of steel, and 2 units of transportation? So if this is our D, and recalling from earlier in the problem, this is the A matrix, then we can find X by working backwards and using this equation. I minus A inverse times D gives us X. It is absolutely fine, and you should and you need to use your graphing calculator for all these steps. You just need to record the work for me like follows. So I've got all of what I would expect to see written or typed out on your paper given below, but I'm going to show you how to actually do it in the calculator over here. So that's why I've switched to my laptop from my tablet. So these are the 3 steps that are required to do this equation. The first thing you need to do is find I minus A. So recall that I for a 3 by 3 are the ones on the diagonals and the zeros everywhere else. This is our A matrix and we need to subtract those. And I've already got the answer written over here. But to do that in your calculator, if you wish to, I know you can probably do this one by hand. Like you can take 1 minus 0.02 and 0 minus 2 and 0 minus 0.01. That's not hard. So you can certainly do this by hand if you want to and get to these values. That's totally fine. But you're going to need a calculator to do some of these later steps anyway, so I'm just going to go ahead and go right to it. So what I've done and what you might want to pause and do for yourself now on your calculator is I have put in the A matrix right here as my matrix A, and I have put the identity matrix in as matrix B. So if I look at these, if I quit these, if I just call up matrix, if I call up matrix A and look at it, you can see that that's this matrix. And if I call it matrix B and just look at it, that's my identity. So the first thing I want to do is I want to find I minus A. So I can do that. I can say, okay, let's call up my I matrix, which for me is B. And then I'm going to subtract the A matrix from it. And what I'm going to do, I want to keep a store. So I'm going to store that in a matrix. I'm going to store that in matrix C. Okay, so I get this matrix right here. And not only that, but what's so nice about that is that now if I go in under my matrix menu, I now have created a matrix C that has this stored in it. Why that's important or helpful to get this into your calculator is because your next step is to find the inverse of this. So I can just simply go out. I can now call up my matrix C, which is this this subtraction right here. And I can say, hey, calculator, please give me, I just hit the inverse button on that. And again, if I just hit enter, then it's going to calculate the inverse for me, but I want to keep running totals of everything. So I am going to store this back in a matrix. I'm going to skip matrix D because I actually have a matrix D that I need to use here. I'm going to store that in matrix E for myself. Okay, so what I've written down here is just a estimation, a rounded off version of what all of these values are. And I'm not even sure I can show you on the screen there. I can show you what all those entries are. So I've given the rounded off versions here. And that's what I would want you to write down, is just something so that I could quickly check it and say, yeah, you either did this right, I can tell you did it right, or no, you're off at this stage. Because then for your last step, what you want to do is multiply this inverse that we now have stored in E. We want to multiply that by this D matrix. So I'm going to just go back into my matrices. I haven't created a D, so I'm going to go back up. I'm going to edit. I'm going to edit matrix D to be a 3 by 1 and have entries of 78, 15, and 2. Okay, so I can quit that because the last thing I want to do now is multiply this matrix right here, which I have stored as E, by this matrix D to find my answer. So I'm going to now multiply, oops, clear. Sorry, second matrix call up for me, and you have to multiply in the correct order, right? The insides have to match. So I have to do it in this order. I have to multiply that inverse matrix wherever you've saved that. You can save it wherever you want. Just keep notes for yourself so you know what you're doing. And then I have to multiply that for me times this one, which I have matrix D, and there are my values. So definitely these right here, you're going to want to do some of these steps in your calculator. Just keep me over here a running kind of total of what you're doing and what you're finding. You also might want to keep notes to yourself, like I've saved this matrix as B, this matrix as A, this was C, this one was E, sorry about that, and this one was D, so that you can keep track of where everything is. So what we've figured out when we found this is that if there's an outside demand for the goods given here, if this is the outside demand, then this economy needs to produce a total of 152.73 tons of coal, 35.59 tons of steel, and 49.6 units of transportation to meet both that outside demand as well as keep itself running.